Hello everyone. Today I am going to discuss one problem from Codechef Starters 154. The problem is tree cards or. So what is the problem? We are given a tree with n vertices. We have to initialize a variable x with 0. Now we have to do the following operation n minus 1 times. So we have to choose an edge u comma v that still has not been deleted. Delete the edge u comma v. Okay. Now after deleting an edge, there will be two parts. One containing u and another containing v. So we can do either x equals to x or size of u or x equals to x or size of v. Okay, we have to find the minimum possible value of x that can be achieved after performing the n minus 1 operations. So let's take one example to understand it better. So let's say our graph is like this: 1 2 3 and 4 5. So let's say we are deleting this edge first. Okay, we are deleting this edge first. Then the size of the component containing 4 is what? 4. And the size of the element or size of the component containing 5 is 1. So we can do x equals to x or 4 and or x equals to x or 1. Okay, after that we have to find the minimum value of x. Okay, now this problem is quite straightforward and quite easy. Just some observations are required. Okay, so what are the observations? So first observation is that what will be the minimum value of x? What will be the minimum value of x? Now what is x? X is initialized with 0 and we are performing some XOR operations. So it is guaranteed that the minimum value of x, or you can say that minimum of x is obviously 0 because x could not be negative, right? Now another, this is the first observation and important one, and the second observation is also very important, that if the number of edges are even. Okay, let's say number of edges are even, let's say 1 2 3. If the number of edges are even, we will just remove the leaves from the tree one by one. We will remove the leaves from the tree one by one. Okay, why? Because let's say we are removing this leaf. Okay, and we will just XOR x or 1, because this leaf, after removing this leaf, every leaf will have only one element in the component. So first XOR 1. Okay, first x equals to x of 1. After that these two, any of these two are leaves. Okay, so let's say we are removing this, then it will be x or 1 or 1. Okay, so now every edges are removed, so the final value will be 0. Okay, so if the number of edges are even, then the answer will be obviously 0, and the algo is to remove every leaf one by one. So the algo is to remove every leaf one by one. Now here comes the interesting part. When number of edges are odd, let's say there are two special cases here. So let's say there is only one edge, then the answer should be 1. If there is only one edge, then the answer should be 1. Okay, answer should be 1, that we have to remove this edge. Okay, now if the number of edges are greater than 1 and the number of edges are odd, then there is a special technique to remove the edges. Okay, so that is, let's say 1 2 3 and 4, there are 3 edges here. Now if we just go with our previous approach to remove leaves one by one, then our answer will be 1, because our answer will be x or 1. Let's say we are removing this leaf, then let's say we are removing this leaf, so x or 1s or 1, then after that we are removing this leaf. Okay, like that. Okay, so the answer will be 1s or 1, which will be equals to 1. So this is not the optimal way to remove the edges. So let's draw the graph again and try to find what is the optimal way to remove the edges. Okay, so optimal way to remove the edges is to just to remove the leaves. Okay, just to remove the leaves only. But in the previous approach, we are just XORing it with 1. We are XORing it with 1, the number of elements in the component of the leaf. Okay, but here we have to do something else. We will just remove this edge by removing one leaf, but instead of it with 1, we will XOR it with the other component. So our x will be x or 3. Okay, now after that we will remove the other leaf. Okay, after remove the other leaf, now instead of XORing it with 2, XORing it with 1, because the number of components in this component, we will XOR it with the 2. Okay, so x or 3 or 2. Okay, Now after that we will remove this edge and solve 1. So 3s or 2s or 1 is 0. Okay. So any number of edges we have, odd number of edges, let's say we have 1, 2, 3, 4, 5, 6. There are 5 edges. So we'll remove the previous, remove the other leaves with the same approach. Okay, we'll just remove this edge and we'll XOR 1. We'll remove this edge and we'll do XOR 1. But whenever there are 4 elements left, we will do this special kind of strategy to do ones or threes or twos or one. Okay, now our problem is solved. So the problem is quite straightforward. Just there are few edge cases. The first edge case is that first observation is that the minimum value is 0. The second observation is that we have to just remove the leaves one by one. The edges just pointing to the leaves one by one. And the third approach is that if there are even number of edges, then we'll just use ones or one kind of that. But if there is odd number of edges, then we have to do this special kind of strategy with threes or twos or one. So let's jump into the code. You will understand it better. Okay, so this is the code. Here, the this is like the entire approach is to find leaves of the graph or center of the graph is very well documented problem. So for that we'll just compute the in degree of any vertex. If the in degree is 1, then we know that this is a leaf. Okay, if the in degree is 1, then this is a leaf. So if in degree of I is 1, or you can say degree because this is a undirected graph, right? So you can, instead of in degree, you can call it degree. If degree of I equals to 1, we are just inserting that leaves dot pushback 1, leaves dot pushback I. Now uh, initially n nodes are remaining. I'll say that why I am using this rem. Okay, now we'll just remove the leaves in layers. So in the first layer there will be some leaves. After removing those leaves, there will be some other layer of leaves. So new leaves is the second layer. Okay, so we are operating on the current layer of leaves. Okay, so if a of leaf dot size is 0, we are just continuing it because let's say there is age from 1 to 2, then this is also leaf and this is also leaf, so there is no point of removing two leaves. So that's why if a of leaf dot size equals to 0, we are doing continue. Now parent is needed because we have to also find the path. Okay, the way we are removing the edges. Okay, so that's why parent is a of leaf dot begin. So only one element remaining in the adjacency list of leaf. Now here comes the interesting part. If in percent 2 equals to 0, that means the number of edges are odd because the number of edges are n minus 1. If the number of edges are odd and n is not equals to 2, and okay, and there are 3 or 4 nodes remaining. Okay, why? Because you can see that when there are 4 nodes remaining, we are just doing this part. Okay, 3, we are just doing 3. Similarly, when there are 3 nodes remaining, we are just taking the parent, the component of the parent. Okay, otherwise we are taking the component of the leaf. That's why if in percent 2 equals to 0 and n not equals to 2, the special case, and the number of remaining nodes are 3 or the number of remaining nodes are 4, we are just doing parent, leaf and parent. Otherwise we are doing parent comma leaf. Other part is quite simple. We are just removing the leaf node from the parent's adjacency list, and if the parent adjacency list is size is 1, then it is the new leaf, so we are inserting it into the new leaf array. Okay, and after each step every node is removed, we are doing remove minus minus. Now if n equals to 2, our answer will be 1, otherwise our answer will be 0. I will provide the link of the code in the description box. The problem is quite straightforward. You can, if you have any doubt in any part of the explanation of code, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel, and also share among your peers. Thank you.